Thank you. Okay, so are these two functions? Yes. And what was the line test? What did you guys call it? The what? Vertical line test. Now, what do we do with the vertical line test? We're testing if the vertical line does what? Hits it more than once, right? And if it does not, it is a function. Okay, domain. You see these arrows here. Is the graph going leftward forever? I don't care if it's going up or down. Is it going towards the left forever? Is it going towards the right forever? So what is the domain? Negative infinity to infinity. Range. Range is a set of all what values? X values or Y values? Y values. So you're looking, and does this graph go up and down forever? No, it does not. It goes in which direction forever? It goes up forever from -1? -1 up to infinity. How do we write that if it's going from -1 up to infinity? Bracket. Keep going. -1, comma, infinity parentheses. Good. All right, questions on that one, yes or no? Okay, does it make sense? Okay, again, it's going from -1 up forever, so -1 to infinity. Okay, increase, decrease, constant. Here is where you need to be making sure you're paying attention, and where kids typically struggle. Increase, decrease, constant. You're reading the x-axis and the x-axis only. I'll repeat that. You're reading the x-axis and the x-axis only. That's why this note is here. Remember, only the range is described in terms of y. Everything else is x, 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 and x. Everything else is the x-axis. Bless you. Okay. So I just want you to just trace with your finger on your paper where your graph is increasing. With your finger, just trace on your paper where your graph is increasing. And it might be more than one place. It might be no place at all. You are checking. All right. Is it increasing at all?
Yeah.
In one place, more than one place? One place. All right, I have kids saying, well, this is going up and this is going up. Does that mean they're both increasing? No, because which axis are we reading? And when you read the x, you read from left to right. And when I read this line right here from left to right, is that a walk uphill or downhill? So that's decreasing. This is what? Constant. And this is a walk uphill, which is increasing. All right, where is it increasing from? What x value? 2. Don't put any parentheses or brackets yet, comma, infinity. We'll put our parentheses and brackets in at the end. So just put 2 comma infinity, and I'll describe it and explain at the end. Decreasing. We said it was decreasing from this part to the left. Yes or no? Okay. So am I decreasing from the far left? Yes. So what would I say? Negative infinity, and then where? At what point do I stop? -1. I'll put parentheses and brackets in later. Is anyone struggling with that negative infinity? Okay, I'm going to pose a question that I get asked quite often. You guys can help to clarify. I get asked, why is this negative infinity if my line is coming from positive infinity? Can you clarify that mistake? The question I get asked is, Mrs. Torres, why is this negative infinity, but this arrow's coming from positive infinity because it's coming from the top? We're reading the x-axis, not the y. Do you guys see that? And when I'm reading the x-axis, yes, I'm coming from the top, but from which direction? The left, which is negative infinity. Make sense? All right, constants between what two numbers? -1 and 2. All right, now here's the deal with parentheses and brackets. If you did this, so this is why I'm working in pencil, so don't write with me if you're working in pen. If you said bracket, parentheses, parentheses, bracket, bracket, and bracket, that would be wrong. And here's why. Do you guys see why I would put brackets? Because it's closed. You agree right here at the 2 it is closed. And right there at the -1 it is closed. So why is it wrong?
Because it's not all the point.
Because it's shared, you're right. The 2 and the 2 right here overlap. Do you see that? That -1 and the -1 overlaps. Do you see that? So if you have 2 closed circles on top of each other, it's no longer a function. You're saying that at -1 it's decreasing and it's constant. You're saying it's not a function because you have 2 closed dots that overlap. Choices. Are you ready? You pick, it doesn't matter which one. Like I'm going to make this 2 a parentheses so that it doesn't overlap with that 2. And I'll make, just because I want to, this one a parentheses, so it doesn't overlap with this one. Now, because kids typically mess this up and they're like, oh, I don't know, I allow kids just to put parentheses in all of these and not worry about closed, open, brackets. Now that bothers some kids. So some kids are like, no, I don't like it, it's not mathematically correct. If you don't like the parentheses, you use the brackets. But if you put the brackets on multiple numbers where they shouldn't be, would you get it wrong? Yeah. Yes. So if you get the brackets, you're using them, make sure you know how to use them. If you're like, I don't want to mess it up, I'm okay if you just use parentheses for increase, decrease, and constant. Is it okay to just use parentheses on domain range? No, there you need to have your brackets in the right spot. All right? Because domain is X values, range is the Y values. There'll be no overlap there. Okay, ready? Next one. We already said yes, this is a function. Domain, it's a parabola. There's no restriction. It doesn't matter if it's up or down. What's the domain? Should we know that without even looking at a graph, that a parabola's domain is all reals, -infinity to infinity? Yes? All right. Range. Does my graph go open? Does it open up and down forever? Which direction is it opening forever? Down. So we read from the bottom up. It's coming down to -infinity forever. So -infinity up to what X value? -infinity to what? 3. Parentheses on the -infinity, but 3 is closed. There is no open circle there, so what do I put on the 3? Brackets. Yes? All right. Can anybody answer that question? How did we find the range was the question. Okay, so domain is left to right and range is bottom up. Okay, so when I come from the bottom of my graph, because of those arrows, is this graph going down forever to -infinity? So if I'm coming from the bottom, there's a graph at -infinity, and when I move up, does the graph go up forever? No, it stops at what point? 3. So -infinity to 3. Yes? Makes sense? All right. Questions? Okay, so what do we know about increase, decrease, constant? 2 things we know. In terms of X or Y? X, and so we don't get confused, we're just going to use parentheses. If you don't want to and you want to use brackets, go for it. Just make sure you know how to use it. All right. When I'm here, from left to right, what is this part of the graph doing? Increasing. Do you guys agree? Yes? So from the left side, I'm increasing from negative what? Infinity over to 3 or over to 1? 1, because it's the X values, not the Y values. Decreasing. At the 1, do I start to decrease? And I decrease off to what? To infinity. Now kids will say, isn't it -infinity because you're going down? The kid who does that is doing what incorrectly? They're saying they're not reading left to right, they're reading up and down. They're saying, well, that's going down to negative infinity. Yes, it is, but it's going in the right direction, and the right on the x-axis is infinity. All right, constant. Is it ever constant? You could put none, never, doesn't happen. Don't just leave it blank. 0 with a line through it, I would even accept. Okay, questions on this? All right, next one. Vertical line, test it and see, is it a function? Yes or no? Mm-hmm. Domain. Does my graph go left and right forever? No, according to this picture, which direction does it go forever? To the right. And it goes to the right forever, but it starts at what x value? So what would that look like as a domain? -2, 2. All right, and on the -2, it's closed. There's no, how do we know it's closed? Because there's no open circle, which means it's closed. So what do I put on the -2? Brackets. And domain and range, you don't have the choice of using parentheses. You do need to use your brackets and parentheses correctly. All right, range. Does my graph go up and down forever? Which direction does it go? Is it going up forever or down forever? Up. So is there a graph down here at negative infinity? No, but it starts at what y value? -1, and does it go up forever from there? Yes? To infinity. And what do I put on the -1? Brackets. All right, do not forget, increase, decrease, constant. You're looking at the x-axis, and we use parentheses. Okay, increasing. What do we know about the graph? Is it always doing one thing forever? What is it doing forever? Do you agree it never decreases? It's never constant? So we said none for decreasing, none for constant, and it's increasing from what to what? -2 to infinity. And if you put a bracket on the -2, would that be okay? And you'd be safe because there is no other -2. All right. Questions on any of this? Have you seen this kind of stuff before last year? Do you guys remember what this was called from last year? What kind of graph? Starts with the P. Piecewise graphs. Good job. Okay. Piecewise graphs, we still check if it's a function. So draw your vertical line test. The only place where there is concern is right here. When I draw my vertical line, is there any overlap? Or is there two closed circles at one time? No. Is it okay to have two dots if one is open and one is closed?
Yes.
Yes. So is this a function?
Yes.
Yes. Now, if I went and the graph I gave you looked like this, and that dot right there was closed, would that be a function? That would not be a function. The whole thing is not a function because of that two dots being closed at the same x value. All right, domain. Okay, I'm going right here. Is this graph going left forever? Okay, so I'm going to come in from the left infinity side. Okay, so there's a graph, 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 and right here at 1, 2, at -3, it's open. But is there a closed circle anywhere else at x equals -3? Yes. So it still counts. And then I'm going to go right. It may not be on this line, but it's on this one. Does this one go to the right forever? Yes or no? Okay, what's my domain? -infinity to infinity. Now, it's not continuous. It is a piecewise, but it's still -infinity to infinity. Does that make sense? Yes? Why wouldn't there be a union? Because there is no x spot where there is no graph. For example, when I do my range, there will be a union because there's a graph, but right here, there's a section on my y-axis where there is no graph. Do you see that? So when I do my range, there'll be a union because when I'm reading the y-axis, there's a section right here on my y-axis where there's no graph. No graph exists, so there'll be a union. When I'm reading the x-axis, is there ever a place where I do not have a graph? The only place that comes close is that open circle, but at that open circle, is there a closed circle somewhere else? Yes. So everywhere, when I trace from left to right, everywhere I go, there is a graph. The graph exists. Do you see that? Did everyone understand her question and the answer? All right. Range. Does my graph go up and down forever? Okay, starting from the bottom with that arrow, is it coming down forever? Yes? So what would I start with? Negative, infinity, a comma, and at what y value does it stop? At what y value? 1, parentheses, and what do I put on the 1? Because it's closed right there. Bracket. Now, is there a graph between 1 and 2 or no graph at all? Do you agree there's no graph in there? So I have to put union. And then where does my graph pick back up? Where is it? At the 2. And does it do anything, or does it just stay there? So we just put a 2. And you can put it like this. You can put it with squiggly brackets.
Is it because it's an open circle that you just add 2?
It's not because of the open circle. It's because it's constant. It stays at 2. It doesn't go up forever. It's just always 2.
But why would it be brackets if it's open?
Because even though this is open, is it closed elsewhere on the 2? Right here? Is all this closed?
Yeah.
Yeah. So at the y equals 2 graph, does a graph exist? Yes, there's an open circle there, but does a graph exist everywhere else?
Yeah.
So it's kind of like this one here. Open, but it was closed there. Open, but it's closed over here. All right. Is my graph increasing anywhere? And I'm reading the x-axis. Is my graph decreasing anywhere? Yes? From what x value does it start decreasing? Negative what? Negative 3. Oh, wow. Negative 3, and it decreases off to what? Infinity. Positive infinity because we're reading the x-axis. Is it constant? Negative what? Negative infinity, and at what point? Negative infinity to what, guys? Negative 3. Now, if those of you are using brackets, if any of you are using brackets, would it be okay to put the bracket on this negative 3? No, I told you guys, oh, it's up to you, it doesn't matter. On this one, it would matter. That one would be the bracket, and this one would be the parentheses. Got it? Bracket, parentheses. All right, questions on any piece here? Okay, backside. All right. Gets confusing when you read this. You want to make sure that you are paying attention. A function is even if for every x in the domain, f of negative x equals x. What does that mean? That means when you plug a negative value in for x, your original function comes out. It does not change your original function. Everybody get that? When you plug a negative value in for x, your original function, or like if you plug a negative x in, your original function comes out. It's odd. It's odd if for every x in the domain, f of negative x is the opposite of the original function. And if neither of these happen, then it's neither. So classify as even, odd, or neither. So on each and every one, we're going to find f of negative x. Plug negative x in and see what comes out. Are you ready? Yes? Okay, so let's plug in negative x. I put parentheses squared minus 5. What am I going to put in the parentheses where the x used to be? What is it? Negative x in parentheses. Negative x squared is what? X squared? All right, so f of negative x equals x squared minus 5. Is that the original, opposite of the original, or neither? Did we get the original function? The original function is x squared minus 5. I plugged in a negative x, and when I simplified it, I still ended up with the original function. Does that make sense? Yes? So odd, even, or neither? Even. What that means is if you were to make a t-chart and plug, can anybody give me a positive value for x? 1. 1 squared is what? Minus 5? Negative 4. And what's the opposite of 1? Negative 1. What's negative 1 squared? And 1 minus 5? So, guys, so when you plug in a positive and its opposite, you're going to get the same x value out either way. Give me another value besides negative 1. 2. And negative 2. What's 2 squared? Minus 5? Negative 1? Yes? Negative 2 squared? 4 minus 5? Do we get the same set here? All right, does that make sense? Okay, next one, let's try it. What are we going to plug in? F or g of negative x, 7 over blank cubed minus blank. What do I put in the blanks? Negative x. Kids struggle with these in the test, and I'm not quite sure why. Maybe just getting more practice. So make sure you're doing your work, you're understanding. All right, 7 over. Negative x times negative x times negative x is what? So it's still negative x cubed, yes or no? It does not become positive. Do you guys agree? All right. Minus x or plus x? Okay. Now, it's kind of hard to tell here if it's the same, if it's opposite, if it's neither. So what I suggest, first off, positive 7 and positive 7 state the same, yes? Take a negative out of the denominator and see if you can tell then. So take the negative out. What would that give you here? And that's what you do. You pull the negative out and see what you can do. Negative x, negative, positive x cubed, and then plus x or minus x. All right, so you're comparing this to this. Obviously, they're not the same because this has a negative on the outside. This one does not. This with the opposite, the negative taking out, x cubed minus x stayed the same. Would you say they're opposites or neither? Are they opposites? Or negative, f of negative x equals negative f of x. So is this the opposite of g of x? Yes, so odd, even, or neither? Odd. Make sense? Yes? Okay. Next one. What are we going to plug in? U of what? Negative t equals square root 3 minus parentheses squared all right, what goes in the parentheses? Negative t square root 3. Do I cross these two negatives out or square first? So 3 minus negative t squared or positive t squared? Positive t squared. So u of negative t equals this. You're comparing to this. Are they the same, opposite, or neither? So odd, even, or neither? Even. Questions? And the last one, we find h of what? Negative s blank squared minus 3 blank plus 1. What do I put in the blanks? Negative s. All right, what's negative s times negative s? Positive s squared plus 3s or minus 3s? And then plus 1. And what did I tell you guys to do? First off, is it exactly the same? Can you tell right away? Is it exactly the same, yes or no? No, there's positive, negative, positive. If it's no, then pull out a negative to see if it's an opposite. Negative, what does this give me if I pull out a negative? S squared plus 3s or minus? Minus 3s plus 1 or minus 1? Now, in order for them to be opposites, once you pull out the negative, whatever remains should be the same. When I pulled out the negative sign, the opposite, whatever remains should be the same. Is it the same? No. Opposite, even, odd, or neither. They are not the same. They are not opposites, because when I pull up the negative, the inside is not the same, so it is a neither. Questions? All right, put your phones away, please, and I do want to go over the graphs. The graphs are on the test as well. Are you ready? Yes? Okay. I'm going to start with evens first. Even. If you fold your function on the y-axis, and it is a mirror image, it is even. So if your graph is symmetrical on the y-axis, it is even. So let's test this one. If I fold this on the y-axis, is it symmetrical? What about this one? So which one's even? Both or 10? Okay, so here's the question. Are all parabolas even? Yeah? No? Okay, what if it's opening up? Would it matter? Okay, what about a parabola that's like this? Is this parabola symmetrical? It's symmetrical, but is it symmetrical on the y-axis, which is what I had said. It has to be the y-axis. So, is this one even? This first one over here I'm pointing to. This one is even. Is this one even? No, we would say neither on that one. We know you don't know odd yet, but I will explain it. All right, even, neither. So be careful with parabolas. The mistake kids make is they're like, oh, it's symmetrical. Yes, but it has to be symmetrical where? On the y-axis. So write that down. Symmetrical on the y-axis. Okay, are we ready? So, this is definitely, 9 is definitely not even, but I haven't given you the rule for odd. Odd, it's symmetrical about the origin. What does that mean? You put your point right here. You don't have to do it yet, just look at mine. And you flip your paper upside down, 180. And if it comes out being the same picture, it is odd. So I flipped mine. Does it still look like yours? Yes, it's going like this and then down? Yes. If they come out exactly the same, then it is what? Odds. So this is an odd. So if you take your paper and you flip it upside down and you still have the same image, it is odd. Now if I moved this cubic function somewhere other than going through the origin, for example, I moved it like this, and that's where it crosses, let's say that's a positive 1, and I flipped it upside down, is it still the same? No, because now this intercept would no longer be 1, it would be what? Negative 1. So in order for it for these cubic functions to be odd, it has to go through the what? The origin. Another function that is like this, something like What graph is that? Do you guys know?
Size.
Sine. It's sine that's been shifted over, or depending on your period length. If I were to, it's top at the left, bottom at the right. If I flipped it upside down, is it still top, bottom? Yes. So that's another example of an odd function. All right, so what kind of test questions will they give you? They'll definitely give you some like this up here where you have to do f of negative x or g of negative x and see if it comes out to be the same, opposite, or neither. And some like this where you're looking to see if it's symmetrical on the y-axis or about the origin. Questions?
That's all we have to write,
Even and odd, or neither. So this one here, this one is odd. What would this one be? Neither. Makes sense. Questions? We're good? Yes.
On the last one,
What was that?
on the needle one,
What about it?
would it be even?
It wouldn't be even because remember, even it has to be symmetrical on the y-axis. So if I were to fold this on the y-axis, would it be a mirror image? This would be the top and this would be going down. So if it was like this, a parabola like that, yes, that would be even. But once you make it that cubic, it is not. Good question. Any others?